So here in the second exercise, we're trying to determine if how somebody's treated will affect their performance. So you can read about the situation here. Basically, somebody was treated poorly. So a group of people were treated poorly, and then they saw their exam results, and a different group was treated not poorly, and their exam results were seen here. So we want to start to understand the data, of course, so we know the proper way to deal with it. One thing that we do need to do for sure is to see if the two data sets are normally distributed. So you can do that by either going to graph and probability plot as we did in the first exercise, but another way that I thought was interesting was to go to Assistant and to go to Graphical Analysis, where here I'm going to do a graphical summary, and I'm going to put in that I've got more than one column. I'm going to put in my columns, and here I want one single report across the two columns that I've got here. And it's kind of nice because what it's going to give you is a lot of information. Here you can see the means and the confidence intervals and the standard deviations. And here even you can see the normality test. So here you can see that both of these particular data sets appear to be normally distributed. You can see that they pass the normality test. So there's just a different way of assessing some of the statistics going on for these two columns. We're actually asked to create side-by-side box plots. So let's go through that and go to Graph and find box plot. Here I'm going to do multiple box plots here where I've got the root and the control group. Okay, so you can see from the box plots that are going to populate here that when we're assessing if they are spread out the same, you can see that this rudeness one is a lot more condensed. So from tip to tail here, a lot smaller than the tip to tail of the control group. So here, when you're talking about dispersion here, what we mean is how spread out it is. So dispersion is indicating that the standard deviation, not the mean or the median. And in this case, you can see that this control group seems to be a lot more variable. So here it looks like they're different. You could also get a little bit more precise by saying stat basic statistics, and then going to the two variance test. So when you go to the two variance test and each sample is in its own column, you can actually verify that these two groups are significantly different. Here you can see the box plots again. They are significantly differently spread because the p-value for Levene's test is very small. So if p-value is big, then we'd say that they are spread similarly, and if it's small, we would say that they are not spread similarly. So in this case, because it's normal, both of these are normal, because the spread is not the same, and because they are independent, so we've got different people in this rude group versus different people in this control group. If you had the same person being treated rudely as well as then a separate time not being treated rudely, then you could pair them. But in this case, they are not paired, so we would be doing a two-sample t-test, but where the variance is not pooled. Okay, going on further, we want to see if the test score for the rude group is lower than for the control group. So here, when you're assessing which hypothesis, when you order rude as the first group, you want to make sure here then that you've got the sign pointing, the little point goes towards the side that's smaller. That's the side that's the less than side. So this is the actual hypothesis that we're testing. To actually run this now, we know that we're going to be running a two sample t test where I've got the separate columns, and I want to make sure that here, because I have listed the group rude first, I want to make sure in sample 1 I've got the group rude first, and then the control group. Going into options, I want to make sure that I don't check this box, because when I verified the box plots, it didn't look like they were spread the same. And when I ran Levine's test, it said the p-value is small. So I do not check to assume the variances are equal. However, I will change the sign in the alternative hypothesis to be the less than sign here. Okay, when I do that, I will get here both the test statistic, the p-value, and of course the degree of freedom. Okay, so here's the test statistic and here's the p-value. Notice in E it's saying a test that's comparing the spreads was found to have a p-value of this. This is not the same p-value that is here. This p-value is for this hypothesis test, whereas this p-value, this is the p-value of the test of spread. In fact, this is actually the p-value of Levine's test. So you can see here, this is the test of this hypothesis. You can see here, that's this guy here. But when I ran Levine's test, let me just go up a little bit. Oops, too far. And I'm having a little bit of trouble controlling it. Wow. Okay, right there. Okay, here is the p-value for Levine's test, and you can see that this is the test not of the means, but of the standard deviations. So this is the p-value to tell you that the standard deviations are different, and this is the p-value to tell you that the means are different. So here, this p-value goes with this p-value goes with the test of spread. We had other p-values that went with the normality, so lots of p-values running around. Okay, so consult the p-value found in part D. So not this guy, but this guy here. And what does it tell you? Notice that here in D, what we were really testing was the test of means. So this indicates that the mean performance of the people that had the rude behavior is in fact lower. I know that because here the p-value is very small, so I will reject this idea and I will say, yes, it does appear that the average of the people that were treated rude is in fact less than, significantly less than the average of the people that weren't. So here the mean of the performance of the people that were being treated rudely is in fact lower than compared to the mean of the performance of the people that were just treated normal. So when you think about then what a confidence interval between the two would look like, we just said that the actual average of the mean is in fact smaller than the average of the normal. So what does that mean? If I have something small and I subtract something that's bigger than it, so for example, if I had 2 subtract 5, we know that the value would be negative. So in this case, if the average of the rude group is in fact smaller than the average of the normal group, we would expect the confidence interval to be negative on both sides of the interval. So I just selected here the confidence interval for rude subtract normal would in fact be negative both on the upper and on the lower bounds.